Well, thank you, Monitorama, for having me. And this is the conference that needed to happen, so I'm really excited to be here. G'day, my name is Brendan. I work for Netflix, one of the largest potential customers for instance analysis tools. But right now, there are no instance analysis tools I actually want to buy. There are countless open source and commercial products for doing instance monitoring, usually using the same SAR metrics exposed as line graphs. There was another one launched last week, and it's a little bit better. It does a few new things, but it's still basically a faster horse. I want a car. I want an advanced instance analysis monitoring solution that takes on the deeper systems analysis. In this space, products are almost non-existent. There are a few that are getting interesting, and we'll hear about one later today, Syste, which I'm keeping an eye on. But usually at Netflix, we have to build our own. So in the last 10 years, there have been many changes in this field. There's more Linux. So a greater portion of your customer, if you're building a monitoring tool, a greater proportion of your customers are probably running Linux, which means the engineers can focus more on one operating system and use all of the things that Linux provides. There's more Linux metrics. I love dynamic tracing, and user level and kernel level dynamic tracing are both now in the Linux kernel. And these expose endless things that we can do to understand the system in detail. We just need tools on top of that to make it easier to use. There's better visualizations. So there's lots of libraries, but they didn't exist 10 years ago, for example, D3. And there's also many examples of using visualizations for systems or instance analysis. So I've created various types of heat maps and also flame graphs. There's also containers, which containers as well pose new challenges for this space. So the time is right for there to be a new instance analysis tool for Linux that uses the new metrics and uses the new visualizations and does container support. But these products don't really exist. I don't see them being created. And I've spoken to many performance monitoring companies about this. Why don't these products exist? One in particular, I really wanted to see them adopt latency heat maps. And I had a meeting with the engineers, and I was expecting to need to explain in detail and go through the use cases. But to my surprise, the engineers said they totally got it. They wanted latency heat maps as well. And so I said, great, why don't you have latency heat maps as part of the product? And they said, they build what customers asked for, and not enough customers had asked for latency heat maps. So my talk is about what customers can ask for in terms of instance monitoring and analysis tools. I think there's over 500 people in this room, so that should help. For vendors, our desirables and requirements, what gets us excited in this space, and also what we are building and open sourcing at Netflix to modernize instance performance analysis. Excuse me while I switch views, it's auto-advancing, which is going to make this even more exciting. So I'm going to just do that. All right, so Netflix has, a lot of people know what Netflix is. We saw a talk from Roy yesterday. Roy does the instance monitoring team, and they build Atlas, the cloud-wide monitoring tool. We have lots of Amazon EC2 Linux. We also have lots of FreeBSD for our CDN. And you'll hear about that later today. So he's talking about our CDN monitoring. And it's also an awesome place to work. We're also hiring like everyone else. And so you can join Netflix and work with me on my team and solve cool problems, or Roy or Sergey. So I'm going to go through 5 areas for instance analysis. The first is desirables. So what this will be is a visual checklist that you can use when you're looking at an instance monitoring tool or analysis product. And this is the sort of thing that I do. When someone's pitching me a product, I say, I want to see the screenshots. Let me just browse them quickly and see what level of visual sophistication your product has. So the first one is line graphs. Basically, all tools have this. I might be looking for the resolution of that line graph, so per second metrics, and also if it's real time or near real time. Useful for seeing the passage of time, how things change. Historical data. Can you zoom out and see the last day, the last week, the last month? Again, lots of products have this. It requires storing those metrics somewhere. Just something visually I can see when I'm browsing an instance analysis or monitoring tool. Summary statistics. There's all sorts of cool things we can do with statistical analysis to turn data into information. This screenshot is pretty basic. I've just got different levels of percentile, but it's another thing that I might visually spot if I'm looking at a demo of your product or looking at screenshots. And that helps me, in this case, the percentiles, understand say the latency distribution in more detail, and I might use those percentiles for triggering alerts. Histograms. So histograms let me understand the distribution in much more detail, and I want to see this as part of monitoring and analysis products as well. I want to see that you can do histograms, or you might do density plots instead, that's fine. This particular histogram is of disk I/O latency, and we can see it's bimodal. And the average or mean latency is in between those modes. So if a monitoring product can only show me average or mean latency, in this case, it's not representative of the data set. It's actually where there's no data. So histograms are great, but distributions can change over time. And that same workload as a heat map looks like this. The heat map is printing a histogram as a column, using color to show how many events fell into a particular time and latency range. In this case, it's a latency heat map. And now we can see for that disk I/O latency, it's bimodal, but the second mode varies from second to second. And also about every 5 seconds, there is a new mode of latency, which scatters latency from bottom to top of this visualization. So that's really interesting information that I didn't see just with a histogram. Heat maps are really useful. And as another example, several years ago, I was debugging a storage array with write latency, and I couldn't understand why write latency had decayed. And this data center was in a noisy place. There were buses. It was out next to a bus stop, and buses were really loud. We had this alarm system, fire suppression system, had a false alarm go off that morning. And I started wondering if audio or sound was causing the problems with disk latency. And so I shouted at the disks. And my colleague videoed it and put it on YouTube straight away. And that video has now had over 1 million views. And that's my 15 minutes of fame. It's already over. But I was actually demonstrating latency heat maps. So what a great product video. If only I'd mentioned more about the company I worked for, if I had the foresight to do that. But it was exciting. And so you can see the latency really spiked up, which was more difficult to see just from line graphs. Frequency trails is another useful visualization. I came up with this for understanding both a multimodal distribution and also to understand the precise location of latency outliers. And so it's a combination of a density plot and a rodent plot. On this particular graph, people have actually turned this into t-shirts. You can see MySQL server latency and you know when it's multimodal. So I'm showing 50 servers at the same time as a waterfall chart. And the vertical line, I've drawn that for the mean latency for all of these. And then I've centered each distribution around the mean latency. And so you can see, if I'm just monitoring mean latency, that isn't really representative of it can imply the wrong thing. It's certainly not a normal distribution. A lot of these look lopsided because you actually have most of the queries are on the left, and then you have this tail of latency, and then outliers, which is dragging out the mean. And so it was just another visualization I did. If your product has this, that means it's more visually sophisticated, and that might make it interesting. Waterfall charts. Also useful. If your product has it, that's great. They do lots of cool things. This one happens to be from Google Chrome. Directed graphs or directed acyclic graphs. Another useful visualization. It's just part of my visual checklist when I'm evaluating your product. You do them, they're useful. Flame graphs is another useful visualization. I came up with this to understand CPU usage, and the y-axis shows stack depth. The x-axis is merely the population. So this is not the passage of time, and each stack is, I maximize merging by sorting them alphabetically. So you can quickly look up and down the flame graph and understand why CPUs are used in terms of code path. These are now used for other things, not just CPU usage, but memory profiling and TCP events and whatever, exposing whatever the event is with the stack traces that led to that event. There's also flame charts. So Google added flame charts to the DevTools, and this is also in Mozilla Firefox. This is similar to the flame graph, but it does do the passage of time on the x-axis. So it means you can attack a different class of issues that are time-based. I would actually prefer both. I want to see both of these for different reasons. And I also want full system coverage from an instance analysis or monitoring tool without having to run all of these. So I already have an instance analysis tool. It's called SSH, and I can log into a server and run all of these. If you want to sell me a solution, it must either do this or be easier to do than this. But that's my instance analysis tool. Also, deep system coverage. So the Linux kernel nowadays has all these cool things like uprobes and pprobes, and all these trace point groups, PMCs, advanced PMCs are being developed using PEB support. So all of this stuff really useful in terms of what can we expose out for analysis and monitoring. And again, when I look at an instance analysis tool, do you use any of this at all? Or do you use none of it? Do you just use SAR metrics and then graph them? Or are you digging deeper into the system? And so I've got various other desirables as well. Safe for production use, documented, open source is valuable if possible, and so on. I've listed some undesirables, or things that aren't so desirable from monitoring products. I don't care too much if you have these in your tool. It might make you look a bit silly, and I might just ignore it. But these aren't that attractive to me. The first one is tachometers, or gauges. I'm really sick of seeing these in monitoring. I'm sick of seeing like a whole heap of them. It's like designing the cockpit of a jet fighter, or actually an old school jet fighter, but nothing modern. Especially with arbitrary color highlighting. It's like, oh, my CPUs are yellow, what does that mean? And then like at 50% they go orange and then red. It's really annoying. So tachometers, not a big fan. Pie charts, I'm not a big fan. Especially for real-time metrics where they move rapidly, and it really should be something that's a line graph. Pie charts are fine if they're used for other things. Donuts are like pie charts, but worse. I'm starting to see a lot of these. And also traffic lights. I don't like traffic lights. I like them when they're used for objective metrics. I don't like them when they're used for subjective metrics, because interpreting them becomes fuzzy, and they become basically useless. So a subjective metric might be IOPS, or latency. An objective metric may be errors, or the latency doesn't meet your SLA. And so those are things we all understand are good or bad, and can be directly measured. But how do you do a traffic light on the number of disk IOPS your system is doing? It depends. It depends what those IOPS are. They may be good, they may be bad. It's not something you can easily put a traffic light on. And just as an analogy, if I were to tell you, you go to another country you've never been to before, and you hire a car to drive, and when you're picking up the car, they tell you, things are a little bit different in this country. For the traffic lights, green means it's probably okay to drive. You may get T-boned on the intersections. You'd be thinking, well, this is crazy. Like, Like, I'm not going to be paying attention to traffic lights. I'm just going to be looking around everywhere like a maniac every time I cross a road. And so it would render the traffic lights useless. So, and I see too many monitoring products where you have this, green is probably okay and red is probably not okay, but it depends. It's like that thing shouldn't be traffic light. Like, if it's objective, if it's clear, make it a traffic light. Otherwise, don't. One thing I did do in the past is, if it is subjective, use weather icons. So a long time ago, I made a tool where the disks could be sunny or partly cloudy or stormy. And it was actually really, it would work just fine because it was a visual indicator that something changed. And weather also conveys that it's a vague metric, a prediction. So it may not be accurate, the weather forecasting. So work it on. Requirements, for instance, analysis. The first one I want to mention is acceptable T's and C's. And I've got an example there of something that's probably not acceptable. And that's where, as a customer of your product, I give you an idea, and then I'm unwittingly giving you the intellectual property rights. I'm assigning the intellectual property rights, transferring intellectual property rights to you by using your product. Check with your legal team. I have in the past, they're happy to help. Companies are also happy to change their T's and C's if you read it and have a problem and you say, well, this is a problem. So check out what they have. Technical debt is the energy vampire for engineers. and I always see people try and sell me these monitoring tools, it's a free trial. I'm not a believer in that there's such a thing as a free trial. There is extra complexity when debugging. So if I start running your monitoring tool, it's got an agent on my server, then every time there's a performance issue, I have to debug your thing as long as my things. It's like, did your thing just update and break my server, or is it my things? It's just another thing on the debugging table when I'm working on issues. And that can be annoying. It could be like kernel modules that you load, or user space things that come out of cron or whatever. It's time to explain to others. So when I'm running your agent on my servers, other people at Netflix, other engineers will encounter it and say, what's this? And so now I have to explain it. It's like, oh, we're just doing a trial, don't worry about it. It's a production reliability risk in case it's running with root privileges and causes an outage. And also can be a security risk. Known overhead. So the overhead of the performance monitoring tool must be known so we can manage it and we understand what that will be. And the T's and C's should not prohibit its collection or measurement. And so overhead can include CPU cycles, file system I/O, network I/O, installed software size, and so on. Low overhead. The overhead should be the lowest that's technically possible. I quite often see instance monitoring solutions where there is a lower overhead possible, but that's on their roadmap. And again, not enough customers have asked. It's like, okay, well, I'm the first customer to ask, please use the more efficient way, because at Netflix, 1% CPU overhead means 1% more servers on EC2, which is a lot of money for us. That may be more money than we're paying you to use your product. We try to avoid things like tracing every function and method call, needless kernel to user data transfers, things like ptrace, TCP dump, libpcap. Event logging doesn't scale. So we really prefer to summarize that in kernel if possible. And scalable. So you may have an instance analysis tool or monitoring tool that just works on one instance and that's fine. A lot of these try to do all instances at the same time and give you like a real-time dashboard. And so, okay, so you have a real-time dashboard that's showing per second what's happening on the instances. What happens when there's 100,000 instances? Are we doing 100,000 network packets, UDP packets, or whatever per second? Like, how does it scale? Does it work? We find at Netflix, we tend to kill monitoring tools that attempt to run across the entire Netflix cloud. And our own tool, Atlas, by Roy, has been engineered to work at scale. So we do have something that does work. Agent Cockcroft has been working on Spigo to do simulations of protocols at scale. And so there are ways you can do, because you may not have, of course, Netflix's environment to test, but there are things you can do to try and get your head around what happens to a protocol at scale. Now, if you have this awesome tool and it has higher overhead, it may just be worth it, and we'll just turn it on and off as needed. So, And then the last requirement is it must be useful. So your instance analysis solution must provide actionable information that helps us improve performance. Methodologies. So methodologies, these pose the questions for metrics to answer. And when I'm looking for a good instance analysis or monitoring tool, it's because I have various methodologies I'm using to solve issues, and I want your tool to support my methodologies. There's a little too much of, here's the SAR metrics as line graphs, how are they useful? That's your problem. Isn't it cool they're line graphs? It's like, no, actually, I already know what I want to do, and I want to see how your tool meets my desirables. It's not like, here's line graphs, it's your problem to deal with it. Just as an introduction to methodologies, I've been documenting anti-methodologies, which might help us explain what a methodology is. So the drunk man anti-method is where you just change things at random until the problem goes away. And that might be a little bit familiar, like I've seen this, I've obviously seen this in the past. Sometimes it works and you get away with it. A real methodology includes things like workload characterization. So workload characterization has been known in our industry for a long time. And the way I've presented it is via who, why, what, and how. And what this does is it poses questions for the load that's applied to a target before you worry too much about how the target is performing. So one of the biggest problems we have when you have a performance incident is it because there's higher load? Did we just release a new series of house of cards, or did we release it early? Or is the problem with the target? So is there the actual architecture or software error that's causing the issue? And so workload characterization focuses on the workload applied, and you may answer that before you get into the weeds of studying your own internals. Just to see how that works, so for CPUs, here is who, why, what, and how. So who would be, which process IDs, programs, users, why would be code paths, context, what would be CPU instructions and cycles, and how's it changing over time. We can do this, so Linux has the ability to answer all of those. And monitoring tools of today, or instance analysis tools, are pretty good at the who. So you can tell me which processors or programs are eating the CPUs, and the how. How's that changing over time? Less good at the why and the what. So show me, okay, I know I'm in the kernel, I know I'm in system time. Why? Give me a flame graph. Or I know I'm in my application. Why? And what? What are the CPUs actually doing at a low level? Did performance degrade on this new instance type because memory I/O has different characteristics, and we have more stall cycles. So I'll explain that. So workload characterization is posing questions, the tool can answer it, not just CPUs, but all sorts of different targets. Another methodology that I've come up with, it's called the use method, and that stands for utilization, saturation, and errors. You begin by drawing a functional diagram of your system. So all of the components in the data path, and then you walk around it and you just look for these three metrics. So this is from an earlier slide, but I've just got the hardware now. So things like I/O controllers, CPUs, DRAM, disks. Well, every single box, what is utilization, saturation, and errors? You'll find some of these are really hard to measure. And some of these you may never have measured ever before. And that's the real value in methodologies, is it's, instead of beginning with the metrics, which may be incomplete, and often incomplete, you're beginning with what you actually want to know, and then you're using that to drive your use of metrics and to come up with new metrics. This is really hard. I've got a website where I go through the use method metrics for Linux, loads and loads of commands, but it's something that we kind of want an instance analysis tool or monitoring tool to do for us. So I've decorated that picture with what I typically see for instance analysis tools. And I typically only see about 8 out of 33 of those metrics exposed. It's also difficult on, say, in cloud computing, when you're running as a virtualized guest, to get some of these metrics, because it requires going down to the hardware level, and maybe that support doesn't exist yet or not. Going through the methodologies helping drive efforts to support that, because we now know and can explain why we want it. So there are lots more methodologies. I've done this in previous talks and books, and they guide our usage of the tools. So I'll finish by quickly going through some of the tools we've been creating. So, and with Netflix, when we create tools, we publish them open source. So, Base AMI. This is what's currently in our Base AMI, which is the low-level platform that microservices are built upon. And we have a lot of sources of metrics. We have Atlas and Vector and SAR, perf tools that I've created. We currently don't have third-party monitoring tools, vendor tools enabled. We have Atlas. And so Atlas is great. It does cloud-wide monitoring, solves tons of issues, has solved tons of issues in the past. It also includes various system-level metrics, which is what I'm interested in. Here I've highlighted CPU, system time, and user time. And I can select a particular instance and use Netflix Atlas as an instance analysis tool. And it gives us historical metrics. So Atlas actually works okay. And Atlas has been open sourced. Vector has been open sourced as well. Vector is a newer tool that we're building to run on just one instance on demand and to give us per second high-resolution metrics. So I can see, I can select a Linux instance and I get various things out. The metrics have been selected based on methodologies, like the user method and workload characterization. So far, if you look at it, you might say, well, Brendan, this is another SAR metrics of line graphs. And that stuff is useful, and so we have implemented that, but we are adding the advanced things. So flame graphs is something we've been working on, and we can now do full Java CPU flame graphs, which is fantastic. And we're rolling this out. So the x-axis shows all of my CPU profiles, and I can see whether the CPU is in kernel time, Java, the JVM, GC, everything. All CPU samples in one pane of glass, in one visualization. And this is really cool. It was not possible previously because Java threw away the frame pointer and you couldn't do system level stacks. And also Java's internal profilers did not have external visibility, so they couldn't see into the kernel and various other things. So you really needed a system level profiler to make this work. And last year I came up with a patch broken JDK. Oracle rewrote it this year and have just integrated it into JDK 8, update 60, build 19, early access, which was, no, I'm really excited, which was only made public several days ago. So it's only been out for several days. I used it yesterday for the first time. You could be the second person to ever use this feature. It's the -XX plus preserved frame pointer. And if you run that, performance might be a tiny bit worse, but it will not use the frame pointer, not stomp on the frame pointer register, so you can get full system level stack traces, say on Linux performance. It's really cool. SAR is another thing that happens to be in our instances, and so we can use that for system activity. These metrics are also in Atlas and Vector. So SAR, I'd use SAR as a backup. If something went wrong with Atlas, which is unlikely, but if I needed to, I could go to SAR, and there's a bunch of things there. I've decorated my diagram with all the SAR metrics. And I've also been developing really deep low-level tools for instance analysis in Netflix, and I put this on GitHub as perf tools. This is advanced custom kernel observability. It's pretty rare that we actually need this. I might be one of the only people that uses this stuff, but it's good that you can if need be. And it uses things that Linux has had for a while. They haven't been well known or marketed, like ftrace and perf events. And just to give you an example of what that looks like, this is perf function count, and I'm saying interval 1 second, show me kernel functions that started with BIO, and just print that out every second. That's using dynamic instrumentation, and it's also doing in-kernel counts. So this is efficient. I'm not dumping a full event log to user space and then processing it. I am only emitting the counts of these function calls to user space. So great for analysis. I just use this as a higher level tool to kind of work my way around the kernel, find areas of interest, and then I can use other tools to instrument the functions, their arguments, their latency, all that stuff. So it can be done. And the last thing we're getting into, although we're not running this in production yet because it's so new, is eBPF. eBPF is efficient, jittered, in-kernel programs that can be run on any events. So trace points, dynamic instrumentation. It's awesome. It can do, so as part of the Linux source, this is a latency heat map. And so it prints it, it's oriented differently than I had earlier. And what's awesome about it is doing it in kernel, so it's really efficient. It's only dumping the summarized data to user level. When I was shouting at disks, I was actually demonstrating a dtrace-based product that did latency heat maps several years ago, and that was doing per second and in-kernel rollups. eBPF in Linux gives us the same capabilities. In fact, it seems to be a bit faster for me because it's jittered as well. That's great. It's actually pretty hard to use to actually program eBPF directly, much more difficult than dtrace is at the moment. And so more than ever, we actually want GUIs on top of eBPF, like monitoring and analysis tools. So eBPF, it's something that really completes the picture for Linux instrumentation. And it's going to make a profound difference to instance level and system level monitoring, since we can do all these things very efficiently than we couldn't before. There should be an arms race to support it. A big wad of eBPF was just included in Linux 4.1. So just picture how long before customers are on 4.1, and you have that amount of time to get eBPF into your products. So we have some time. So in summary, requirements. For instance analysis and monitoring, acceptable T's and C's and technical debt, known low overhead, scalable and useful. It should support methodologies. And when I look at demos and I can browse the screenshots, how visually sophisticated is it and what level of data does it expose? And I really want to see heat maps and flame graphs. And hopefully enough customers can ask at the end of this presentation. Linux has the details available. So, and with full eBPF support, it's only now being rolled in. This is more, it's more likely that we can roll monitoring tools. It makes it more acceptable, lowers the overhead. Thank you. So I might take a couple of questions and then we'll break. And you can also ask me questions on Slack, and I'll post my slides on SlideShare. Anyone have a couple of questions before we run up? Yes?
It's clear you have some very specific ideas about what the monitoring companies, many of whom are in this room,
yes,
should be making. If you were going to pick, you gave a number of really good recommendations of things they should be adding. If you were going to pick one that they should go home and implement, what's your favorite?
The question is, what's my favorite thing they should implement? Flame graphs right now are solving so many problems. Doing CPU level frame, this hosts a whole heap of documentation. You can do it for Node.js, you can do it for all the different languages. Java, as of like 7 days ago, there is the JDK 8 update 60.19 has been patched, it's finally shipped in, which is really awesome. So I think getting flame graph support just solves heaps of problems, differential flame graphs, all that cool stuff. Another question? All right, great, thanks.